Hey guys, welcome to Magoma Nonsense Sub. So today we're going to take a look at collisions. I've told you in the previous video that momentum is just like a collision between two objects. That's what I think momentum is. So now we're going just want to explain collisions. Here they say a collision is an isolated event in which two or more moving bodies or objects exert force on each other over a relative short time. Collisions are short part of everyday lives. Example of collision include passenger colliding with a airbag and a bat hitting a ball. An object motion changes during collision. So what I simply want to tell you about collisions, I want to tell you that collision, they do what they change the overall momentum of objects. That's what I want to tell you. And then if you can take a screenshot and see the information here, they I tried to explain collisions, and I think if I try to explain all of this will simply waste time and this video is going to be long. So what I simply want to tell you, just look at this part here. This part here, guys. And so here they're telling you that when let's take I'm just here, I'm holding my, what do you call this, whatever it is that you hit the golf ball with, and then I hit my golf ball. The force that I am hitting the golf ball is the same as the force that the golf ball is hitting that stick of mine that I'm hitting the golf ball with. And you might ask yourself, if these forces are the same but in different direction, why aren't they not cancelling each other? The reason they are not cancelling each other, because these forces, they are the same in magnitude but in different direction. The reason they are not cancelling each other is because they are acting on different objects. One is in the golf ball and one is in the stick that hits the golf ball. That's how it is. Okay, whenever two objects collide with each other, this causes the total momentum to change. Now I'm going to introduce something new, which is the change in momentum. Okay, just simply look at, just like in this car, it means that this car hit the wall, and then you can see that we can see the mass has decreased, because it is, if it was, let's take it was 100, it was 1000 kg, it is no longer going to be 1000 kg. Maybe it's going to be 9000 something. What am I saying? Maybe, somewhere there, 900 something, somewhere there. No, not 9000. Maybe it will be 998. It will lose maybe 2 kg, 1 kg, or maybe 0, something kg. Okay, if the velocity of an object changes, the momentum of an object also changes. If the velocity changes of an object, it means that the momentum will also change. Okay, and then if the mass changes, it means that the total momentum will also change. And then there's a formula to calculate the change in momentum. The change in momentum is simply the final momentum minus the initial momentum. It means you're going to calculate the momentum at first before collision, and then calculate the momentum after collision, and that's where you're going to get the change in momentum. Okay, and then here there's a worked example. They say in figure 1.6, which is this one, a tennis ball with a mass 57 gram is traveling horizontally at 20 meters per second. The ball is struck by a rocket and moves horizontally at 30 meters per second in the opposite direction. Okay, number 8 is you must calculate the change in momentum of the tennis ball. Okay, you want to calculate the change in momentum. When we want to see, what do we have? We have the mass, but the mass is in grams. So I said that the mass must be in kilograms. Okay, so we want to convert kilograms to grams. It means you're going to divide by 1,000, not thousands, 1,000. And then when you take a look at the final momentum, it's going to be 0,057 multiplied by a negative 30. And you might ask yourself, why a negative 30? Just listen to me and listen to me carefully, okay? The tennis ball, let's check, it went to the right with 20 meters per second and then went to the left in 30 meters per second. It means they are different direction, and I've said that a velocity is a vector. It means it must have direction, so that's why it's a negative 30. You cannot say it is 0,057 multiplied by 30 to the left. No, that does not make sense. So we include a negative sign minus the initial. For the initial, it's 0,057 multiplied by a 20, which is positive because it is going to the it's not going backwards. It's not like it hits something and then going back. When something hits something and then goes backward, the velocity becomes a negative. Okay, guys, so then you'll get that, oh, the change in momentum is actually a 2,85 kilograms to the left. Okay, guys, and then note the following: the negative sign shows the direction of the ball. The negative sign shows the direction of the ball's momentum change. This is a way of the rockets to the left. It means there's the reason the momentum of this system, we can call this a system, it was negative, but we cannot write it as negative 2,85. No, we write it as like it is positive, but you change the direction. It is no longer going to be to the right, it's going to be to the left. If they said a direction, maybe they told that it was east or west. If it was west, we're going to say east. Okay, and then this is another example of not a tennis ball, a basketball bouncing off a floor and then going backwards. So the velocity here, it was going to be positive, but here it is going to be negative because it was positive. Let's take here, it was 3, it's going to be 3 meters per second, and then here maybe it's 1 meters per second. This is going to be negative 1 meters per second. That's when you're going to use that to calculate the change in momentum. And again, guys, thank you for watching. Don't forget to like and subscribe. Bye.